Hey everyone, we're going to be doing a video today called Completing the Square. This is a technique that is very important and is necessary for your use in vertex form. Bear with me because I do anticipate this being a longer video, but it's important to really understand all of the steps that we are following when we are going about completing the square. So, it's obvious how useful vertex form is. How do we get there when we are given standard form? Because you're not always going to be given your quadratic in a nice perfect form for you. The first thing we need to recall in order to successfully do this is our perfect square trinomials. So an example of a perfect square trinomial is y equals x squared plus 6x plus 9. Why is it a perfect square trinomial? Well, I know that a is a square because a is just 1. And I have an x squared. C is a perfect square, being 9. And I can check to double to see here, if I do 6 divided by 2, that's 3. 3 squared is the same thing as my 1 times my 3, so 3 squared is just 3. And we can jump straight to this because a is equal to 1 here, so I can say, okay, 6 over 2 squared gives me c. 6 over 2 squared gives me c. 6 over 2 being 3, 3 squared is 9. That is the key for our technique called completing the square. And before we move into there, I want to ask you a hypothetical question here. What if we didn't have c in our parabolas here? I wanted to make these a perfect square trinomial. What if I didn't have c? How could I find c using the b in order to make this a perfect square trinomial? Well, in order to find c, I have to do b divided by 2 and that whole thing squared. b divided by 2, in this case, is going to be 6 divided by 2, which is 3. 3 squared is 9. Let's do this one. I have to do 8 divided by 2, which is 4. 4 squared is 16. Lastly, let's do negative 14 divided by 2, which is negative 7. Negative 7 squared is 49. So the key here, and I'm just going to write this a little bit bigger, is that c is equal to b over 2 squared. I took my b value, divided it by 2, and then squared it in order to get my c value. That is a technique that we are going to use. In order to complete the square, we basically need to find a perfect square trinomial that is hidden within our standard form, because I can factor my perfect square trinomial to give me this. This is the key in our vertex form. Everything else will fall into place. A will fall into place and k will fall into place. We need to find that x minus h all squared. We need to make this happen. Okay, let's really walk through one example and then we'll do some others a little bit faster. Complete the square to move from standard form to vertex form. First things first, let's start with our example. Y is equal to x squared minus 6x plus 11. The first thing that we need to do is put our first two terms in square brackets. Our first two terms are x squared and negative 6x, so I'm going to do that. And I'm going to highlight every step along the way just so we can match it up. So we're putting them in square brackets, and you'll understand why square in a second. I then need to common factor out a. A, in this case, is what's attached to the x, and a is just 1. So I'm going to common factor out a 1. And the next problem that we're going to do, this will be a different number. Obviously, you don't need to actually factor out a 1 because it's just 1, but I'm going to go through the process of showing you where the 1 is going to land and what it's going to do for us throughout all of this. Then what I need to do is I need to make my middle bit here in our square brackets, I need to make that a perfect square trinomial. So just like we had before, I'm going to leave a blank. I need to figure out what that value is going to be. Let's figure out what c is going to be. I'll do that in a different color here. So C is going to be equal to b over 2 squared. Well, what is b? B is negative 6. So it needs to be negative 6 divided by 2, all squared. Negative 6 divided by 2 is negative 3. And negative 3 squared is 9. So the number that I need to stick here is 9. I'm going to add a positive 9. But I can't just add numbers randomly to my equation. That's making it a totally different equation. So I need to add and subtract. I need to add and subtract my new C value. That's the only way that mathematically we are going to have the exact same equation as what we started with, because, you know, plus 9 and negative 9, those would cancel out. They would be nothing at the end of the day. So mathematically, I have the same question here as I started with. But we know that something else is going to be happening because we are putting it into a vertex form. So I need this little bit here because I need to grab that perfect square trinomial. Step number 4 says isolate the perfect square trinomial, and that's where our curved brackets are going to come into play. So I'm going to have y is 1, x squared minus 6x plus 9, and all of those in my regular parentheses, minus 9 within the square bracket plus 11. So all I have done here is I have added brackets to my perfect square trinomial. I'm just isolating what that looks like. Step number 5 says factor my perfect square trinomial. So let's go ahead and factor what's in those curved brackets there. A perfect square trinomial is going to be x and then half of my b value, so negative 3, not negative 3x, just negative 3 squared. And then I still have the minus 9. You cannot forget the minus 9 plus 11. So what I have done here, I factored my perfect square trinomial. And now we have that all necessary squared value that is going to come into play when we are graphing our vertex form. Step number 6 says expand to get rid of the square brackets. So I still have square brackets here that are useless, or that, you know, right now they're useless because I have a 1. So I need to expand my 1. So it's going to be 1 x minus 3 squared. And then I need to expand 1 and negative 9. 1 times negative 9 is just negative 9 plus 11. So nothing really to see there except I expanded using distributive property. And finally, I can simplify. I'm going to simplify. I don't need to actually write my 1 out front, so I'm going to just get rid of it. And I can combine negative 9 and 11 to be positive 2. So in that case, that's the only real thing to highlight here. Okay? And so we have our final version. This is our vertex form of the equation that we started with. Just to recap, I started by putting my first 2 terms in square brackets. I then common factored out my a value, and an a in this case was just 1. I then needed to complete the square. I need to create a perfect square trinomial by adding 9 and subtracting 9. I then isolated my perfect square trinomial and squared it and factored it properly. And then I just cleaned things up by expanding and simplifying. So my final equation, vertex form, is y is equal to x minus 3 squared plus 2. And so what is the vertex of my parabola? This is the original parabola we started with. Well, my vertex is going to be located at 3, 2. We got that straight from our vertex form. Okay? It's a lot of steps to remember, but really once you get the hang of it, it's going to be okay, and you will really know where to go and what to do. Let's do a second example here. Determine the vertex of the following. Y is 2x squared plus 12x plus 11. Okay, that's not so bad. So first things first, I need to isolate my first two terms using square brackets. I then need to factor out a, and a in this case is 2. So I'm going to pull out a 2, leaving me with x squared plus 6x, all plus 11. Okay, that was a step that we didn't really get a chance to appreciate in the previous example because we were just factoring out a 1. So the 2 in this case is very key. I now need to create a perfect square trinomial. I'm going to figure out what c is over to the right here. C is b over 2 squared. B is 6, so that's going to be 6 over 2 squared. 6 divided by 2 is 3. 3 squared is 9. So C is going to be equal to 9. So the number that I have to plus and minus is 9, giving me x squared plus 6x plus 9 minus 9 plus 11. Okay, looking very similar to our last example, but that's okay. I now need to isolate my perfect square trinomial, so I'm going to add brackets around my first 3 terms here. And here we need to remove our square brackets, we need to factor first. Let's factor this perfect square trinomial. That's going to be x plus 3 squared. Everything else stays the same. And now we need to remove our square brackets. And in order to remove our square brackets, I need to distribute the 2 into both terms within the bracket. So it'll be 2 times x plus 3 squared. And then 2 times negative 9, which will give me negative 18. And then I still have this plus 11 that's along for the ride. Okay, we're almost there. We just have to simplify. We're going to pull those last 2 terms together, giving me y is 2 times x plus 3 squared minus 7. That is my vertex form. Okay, the question did ask, what is the vertex of my parabola? So the vertex of my parabola, I can simply say, therefore, the vertex is located at negative 3, because it's the opposite of what's inside the bracket, negative 3, comma, negative 7. Okay, same steps as we did before. This time we just had an actual a value that needed to be factored out. Let's do a more difficult one. Y is equal to negative 3 over 2x squared minus 12x. This is obviously more difficult because we suddenly have a fraction here, but let's figure it out. Start by pulling my first 2 terms into square brackets, and while I only have 2 terms, that's fine. Negative 3 over 2x squared minus 12x. Now I need to factor out my a value. So we're going to pull y is equal to negative 3 over 2 times x squared. And now I need to figure out what negative 12 divided by negative 3 over 2 is. I'm going to do that math over here. Negative 12 divided by negative 3 over 2 is the same thing as negative 12 times negative 2 over 3. Negative 12 times negative 2 gives me 24 over 3, which leaves me with 8. So I have I have a positive 8x here. Okay, now I can go ahead and I can make what's inside my bracket here a perfect square trinomial. In order to find my c value, I have to take 8 divided by 2 and then square it. 8 divided by 2 is 4. 4 squared is 16. So we'll have a plus 16 minus 16. Let's keep going. I now need to separate or isolate my first 3 terms. And then I can factor my perfect trinomial here, my perfect square trinomial. Okay. Next, I need to now remove the brackets by distributing that negative 3 over 2 in. So I'll have negative 3 over 2 x plus 4 squared, and then I need to multiply negative 3 over 2 times negative 16. So I'll just do that over here, negative 3 over 2 times 16, or negative 16 I should say. We have to do that negative 3 times negative 16, which gives you 48 over 2, which is just 24. So I'm going to have a positive 24 here. And recall that the question was originally asking determine the vertex. So what is our vertex of our parabola here? I just can write therefore the vertex is located at negative 4. Remember, it's the opposite of what's inside the bracket, comma, 24. Okay? So a little bit more difficult because we did have a fraction out front here, but all of the same steps work as well. Okay? And that's it, folks. That's how you complete the square.